Alright, let's see a live demo of the Hypothesis Ghostwriter. First of all, of course, you can see the help text if you ask for it. We've got various options and flags that you can see, as well as a few suggested things. So let's start by getting the Ghostwriter to produce a sort function for us. Of course, there's no sort built in, so let's look at sorted instead, the actual thing. You can see here that Hypothesis has already noticed two arguments that we forgot to test in our earlier demo. That is the key function and whether or not to sort in reverse order. But the other thing to note is that it's just said sorted, so it's just called the function without any assertions in the body of the test. This is surprisingly useful, but we can do better. Hypothesis knows about idempotence. That is, if you sort a thing a second time, it shouldn't change anything additional to sorting the first time. And if we ask Hypothesis to test that, you can see it does indeed check that the result and then the repeat result are equal. That's not the only test we can write though. We could check that two functions are equivalent. And this one is actually pretty useful if, for example, you have a multi-threaded version compared to a single-threaded version, before and after refactoring, or a simple slow version like perhaps bubble sort compared to a more complicated but faster version in production. The classic properties also work too, so if you have commutative or associative properties, you can write tests for those. I'll admit though, these don't tend to come up as often as what we call round-trip properties, which just about everyone has. If you save data and then load it, and you want the original data back, you can write a test like this, that asserts that if you compress the data and then decompress it, or save it and load it, you should get exactly the same data you started with back. This one's crucial because input and output and data persistence tend to cross many abstraction layers, so they're surprisingly error-prone, but also they're surprisingly easy to write really powerful tests for. So, for pretty much everyone, I would recommend writing these round-trip tests. Let's look at a more complicated example with JSON encoding. With JSON, the input is more complicated because it's recursive, and frankly, the encoding options are also kind of scarily complicated. I mean, just look at how many arguments there are here. Fortunately, we don't actually need to look at all of these, so I've just trimmed it down, and that's going to look like this. So we say, well, given our object is recursive, so we have none or booleans or floats or strings, that's JSON, or we have lists of JSON, including the nested lists, or dictionaries of string keys to JSON values, including maybe nested lists and dictionaries. But we've still preserved these other things, so we may or may not disallow nan, we might or might not check whether we have circular objects, we might or might not ensure that the output is ASCII instead of UTF-8, and we might or might not sort the keys in all of our objects. So these are nice just to let vary because we're claiming these should have no impact on the actual body of the test. Let's see if PyTest agrees with us. So this is pretty simple. We have a test function, we just run it, and we've been given two distinct failures by Hypothesis. In the first one, we've discovered that, of course, the floating point not a number value is unequal to itself. Yay for not a number. We'll see more of it later. And as our second distinct failure, we've discovered that if allow nan is false and we pass infinity, then encoding is actually invalid because this is a violation of the strict JSON spec. So I'm going to fix that. In this case, we'll just say, well, we will always allow non-finite values just for the purpose of this test, and we'll assume, that is, we'll tell Hypothesis to reject the input if it's not equal to itself. That's like an extra powerful assert. And then if we run this version, what do you think we're going to see? In this case, we see that Hypothesis finds another failing example. If you have a list containing nan, then it actually compares equal to itself. This, it turns out, is thanks to a performance optimization in CPython. For list equality, it will compare itself to the other list by identity first, which allows you to skip the cost in performance of doing deep comparisons when you don't need to. The only problem is that nan kind of breaks the object model. So I'll instead do the correct fix, which is to just pass allow nan equals false to our input generator. And so This ensures that we'll just never generate nan, and with allow nan equals just true, we'll also allow non-finite examples. And this test finally passes. All right, back to the talk.